Alright guys, so now that we're done with our warm-up all about adding fractions with like denominators, we are going to get into today's lesson. So starting today, we're going to, as you guys know, we have 20 kids in our class. So I'm going to have to ask that 10 of you guys go stand in that corner of the room, and then you 10, I'm going to ask to go stand in that corner of the room. So go ahead and do that for me. So now that you're in those corners, can anyone tell me what fraction of you guys are standing in that corner of the room? Good. So we have 10 over 20, right? So is there another fraction that also represents the same number? So is there another fraction that shows how many kids are in each corner of the room? Good. 1/2, right? So I know some of you guys are looking at me like, how the heck is the same fraction, or different fractions representing the same kids in different corners? Well, you guys know how to reduce a fraction, right? So if you take 10 over 20, how can we reduce that? What can we divide both the numerator and the denominator by so that it reduces down? What do you say? Okay, you want to do 2? So if we divide 10 by 2, and we divide 20 by 2, what do we get? We have 5 over what? 10, good. So now, can that reduce further? Right, so you can reduce it by 5 in the numerator and the denominator, correct? And that reduces down to 1/2. So these two fractions are equal because when you reduce 10 over 20 down, it ends up being 1/2. So this concept of two fractions that can be equal even when their denominators are different is something that we're going to use in today's lesson. So today we're going to learn all about adding fractions, adding or subtracting fractions. Whoa. With unlike denominators. Okay? So to do this, we're going to use an example. But using the example, while we go through it, we're going to go over the steps that are involved in solving these problems. So our first problem is going to be 1/2 plus 1/3. Okay, so as you guys know, like we went over yesterday, the best way, or the only way to add two fractions together is for what? Is for their denominators to be the same, right? The same or equal. So what do you think the first step to adding these two fractions is going to be? Good. We're going to have to find so that both fractions are going to be the same, or both denominators. So what are we going to have to do to make sure that these two denominators are the same? We're going to have to find what's called the least common denominator. Now this is a term you guys might not be familiar with, but I know you guys know what multiples are and you know how to find the least common multiple. So the least common denominator is really the least common multiple It's really the least common multiple of the two denominators. So what we have to do is find the multiples of each of these two denominators so that we can find the least common one. So the first thing we're going to do is we're going to go through the multiples of 2. So why don't you guys list the multiples of 2 off for me? So we have 2, 4, what's next? Good. 6, 8, and then we'll do one more, 10, okay? Now let's do the same thing for 3. We have 3, and then what's the next multiple of 3? 6. Good. One more? Okay, 9. So now when we look at our two lists of multiples, do we have one in common? Yeah, we have 6, right? So now we know that our least common denominator, or least common multiple of the two denominators is 6. So we know that we want to create fractions based on these ones with a denominator of 6. So that's going to be our second step. So we're going to create new fractions with the least common denominator. So I know this looks better, but there's an easier way to write it. So we're going to write the same problem vertically instead of horizontally. So it's easier to convert our fractions. So we want to get it so that this fraction has a denominator of 6. And the same thing with this fraction. So what do we have to do so that our denominator here ends up being 6? What can we multiply 2 by so that our denominator ends up being 6 over here? 2 times what gives us 6? 3. Good. So now, as you guys know, whatever you do to the denominator of a fraction, you have to do to the numerator. So we're going to do the same thing up here. Now, 1 times 3 is what? 3. Good. So we know that we converted 1/2 to 3/6. So we have to do the same thing down here to 1/3. So what do we have to multiply 3 by to get to 6? 2, right? Now, we have to do the same thing to the numerator, right? So if we multiply 1 by 2, what do we get? 2, right? So now our third step is just going to be to add and subtract the fraction. And then reduce. So, like in our lesson yesterday, we know that we just have to add or subtract the numerator because we leave the denominators the same. So, what do we get? 3 plus 2? Good. 5, and then over what? Over 6, right? Because we already had that as our denominator. So, can we move this 5 over 6? No, right, good. So, this one's all done. Any questions about that? Okay, good. So, we'll do another example. Just so you guys get more comfortable with it. So, our next example is going to be 4/6 minus 1/5. Okay, now you guys can look at the list again, look at our list of steps, and what do you think the first thing we have to do is? Awesome, we have to find the list of multiples for both 6 and 5. Okay, so let's do 6 first. What are multiples of 6? 6, what's next? 12, good. Then what? 18, 24, let's do one more, and 30. Awesome. So our next one is going to be 5. What are multiples of 5? Okay? So we have 10. What's after 10? 15. These ones are easy, right? 20, 25. What's the last one? 30. Perfect. So now, let's look at our two lists. Do we have a common multiple? Good, it's 30, right? Okay, so what's our second step? Now that we find our least common denominator, we have to create the new fractions, right? So how do we do that? We're going to put them vertically. We're going to create our new fractions, right? So what do we want our denominator to be again? Good, 30. So what do we have to do to convert 4/6 to something over 30? What do we have to multiply 6 by to get to 30? 5, good. So, what do we have to also multiply 4 by? 5, right? And then what do we get? 4 times 5 is 20. Awesome. So now, we have to do the same thing as the second fraction, right? So, 5 times what gives us 30? 6, okay. And now, what do we have to do to the top? Good, also multiply it by 6. So 1 times 6 is what? 6, right. So now, we created our new fraction. So what's our last step? To add or subtract them, right? So in this case, we have to subtract. So what's 20 minus 6? 14, right? Over, what's our denominator? 30, good. Now, can we reduce this fraction? Yes, okay, what do we want to reduce it by? 2, good. 14 divided by 2? 7, okay. And 30 divided by 2? 15. Perfect. Any questions? Any trouble with you guys? Okay, good. One more thing I want to cover with you guys. So, in those two problems, I know some of you guys like to come up with shortcuts and you want to go through all the steps. In those two problems, we had 1/2 plus 1/3, and we had 4/6 minus 1/5. Now, in this one, we came up with an LCD of 6, and in this one, we came up with an LCD of 30. Now, I know you guys are looking at these ones like, oh, well, all I have to do is multiply 2 times 3 to get my LCD of 6, and 6 times 5 to get my LCD of 30. Now, that happened to work out in these two problems, but that's not always going to work. That won't always be the easiest LCD. So what I want you to do is to always follow these steps. Because say I were to give you a problem like 12 over 32 plus 24 over 64. Now, are you guys going to multiply 32 times 64 to find your LCD? I didn't think so, because I'm not either. But if you were to use our technique here and just find the multiples, what's 32 times 2? 64, right? Now, the same thing we're going to do for 64, but we don't even have to find any more multiples because 64 is already our least common multiple. So we're already done with this one without ever having to multiply these. So don't try to do the shortcuts. We're just going to always find the least common multiple. It makes it easier on us, and then it's less reducing we have to do later. So now we found our least common multiple. Let's just finish this problem out. So what do we have to multiply 32 by to get to 64? 2, right? Now what do we do to the numerator? Also multiply it by 2. What's 2 times 12? 24, good. And 64, what do we have to do to get that to 64? What do we have to multiply it by? Just 1, right? Because it's already at the number we're looking for. So we do the same thing to the top. And we end up with 48 over 64. Now, can we reduce that one more time too? Right, reduce it by 2. And we get 24 over 32. What do I want to divide those by? 8. Oh, that's good. And we get 3/4, right? Awesome.